Hello, everyone. Good afternoon. This is Mohammed Sharif from Romic Engineering. Thank you for joining our webinar today about crossing the bridge from design to optimization. We will talk today about the ModSim, modeling and simulation, and the Delmia digital manufacturing. Hope it will be a fruitful webinar to you. We will just take 2 to 3 minutes until others will join us, and we'll come back again. So yes, we can start now. So this is Mohammed Sharif from Romic Engineering. I'm a sales engineer. Don't hesitate to contact us on the mail shown here. This is the agenda of our webinar today. We will talk about the digital continuity and going to the ModSim in a brief or introduction, small introduction, and the capabilities and values for ModSim. And we will talk about Delmia and the virtual twin values. So let's start with Bromic. We are Bromic Group. Our headquarters is in Egypt, starting since 2003. We opened our office in Saudi Arabia in 2006, and our UAE office in 2015. So during these last 22 years, we are trying to focus on the customer needs or customer objectives by integrating our solutions with their current solutions, with the reliable solutions as well. So starting from 2003, we are trying to develop the industry in the Middle East region, not only in Egypt. And starting from 2012, we are trying to playing our vital role, implementing the Industry 4.2 by providing solutions like additive manufacturing and digital management and system integration and industrial Internet of Things, IIoT. So Bromic Group diversified for 3 sectors. This is an example of our partners. The source system for CAD, CAM, and CE solutions. Sorry, I will share my screen again. So, as mentioned, this is a sample of our technology partners, the source system for CAD, CAM, and CE solutions, Carrioform for measurement, 3D measurement solutions, 3D laser measurement for reverse engineering and inspection, Teleroption as well for measurement solutions like roughness, roundness, and alignment, 3D systems, and SLM for additive manufacturing from plastics, composites, and metal, and LK Metrology, our partner for CMM machines. And this is a quick sample of our success stories in the region, in Saudi Arabia, and Egypt, and UAE. So let's start talking about the 3D Experience platform. 3D Experience platform powers our 12 brands according to what they stands for. The first quadrant you can find the social collaborative apps, and the second for 3D modeling, and the third one will be for simulation apps, and the last for information intelligence apps. Actually, we serve 12 different industries with tailored industry solutions to address their specific challenges. And to deliver this value, the platform is uniquely positioned to enable clients of all sizes to create a virtual twin experience by combining the power of science for modeling and simulation, and the power of data science to combine projects and real-world evidence and cooperation. The platform as well provides all of a full set of collaboration services supporting short-term to long-term, enabling, as an example, real-time command and control for operations or continuous learning, supporting long-term quality improvement. Talking about the data science enables us to connect and leverage any type of real-world evidence and big data like IoT, text, images, 3D, and events in any language from any source. A virtual twin experience is much more than a digital twin. So the digital twin is a 3D representation of a product or factory or an enterprise on which you can project the past or current data. A virtual twin extends and improves a digital twin by not only seeing the past, but also navigating the possible future. The virtual twin has built in the realistic behavior of the system so you can run what-if scenarios and see the impact decisions before they are made. So Dassault System built the technology foundation of Simulia, beginning with Abacus acquisition in 2005, combining Abacus with the original CATIA analysis products. Since then, our commitment to simulation technology has accelerated, incorporating best-in-class technologies into Simulia and other brands, from structure to multi-body dynamics to electromagnetics, computational fluid dynamics, fiber acoustics, and more. And our vision and target is to put multidisciplinary simulation-based workflows at the heart of industrial product engineering and innovation. So today we have a multidisciplinary portfolio with solutions available in all of these physics disciplines, supporting many domains. The first is an integration between disciplines. A few such interconnections are shown here. We are talking about much more than simple multiphysics. We are talking about model order reduction, automatic substructuring, and model order change, and co-simulation, whether simultaneous, in parallel, or as a part of an extended sequential simulation process that you can manage and replay. Second, the platform allows us a big step forward toward the digital simulation-centered enterprise. While this chart speaks to the simple exchange of data in an email-based versus an integrated environment, digitalization is more than this. Digitalization on the platform removes the bottlenecks that embed the use of simulation and prevents simulation from becoming widespread. The third benefit is tight integration between CAD and CE, including third-party products, but in our case, especially with CATIA and SolidWorks, on the 3D Experience platform, modeling, CAD, and simulation, the CE, are together in a unified capability called ModSim, which breaks down the silos between the engineering and simulation department. But ModSim is more than just CAD and CE integration and left-shifting simulation into early design phases. It's about substantially accelerating the efficiency of simulation-based design by heavily automating most of the manual work involved in data transfer, geometry cleanup, and model building. ModSim is an important value for simulation users and for the simulation-driven enterprise that is enabled by the 3D Experience platform. The next slide, we will watch this video before dive into the ModSim.
Emerge and issues arise during the journey from idea to finished product.
These detours can impact both your timeline and your bottom line.
How do you fix this? Through the real-time union of modeling
and simulation.
By designing and testing together throughout the process,
you and your team will be able to stay in sync,
determining the best strategies,
eliminating distractions and errors,
and enabling innovations you hadn't even considered,
resulting in something that's far more than the sum of its parts,
while spending far less time and money to get there.
No matter what your challenge or your industry.
By seamlessly uniting modeling and simulation,
teams can learn and explore together,
transforming and accelerating the innovation process.
So thank you for watching this introduction video. Dive into the ModSim concept. So unifying modeling and simulation in a common data model within a single user experience on the 3D Experience platform to accelerate innovation in physics and engineering through cross-disciplinary collaboration and streaming workflow for system architects, designers, and analysts, and decision makers who develop products and services. So the ModSim processes are cyclic rather than linear. In a ModSim loop, modeling processes such as geometry cleanup, meshing, connections, and simulation processes such as adding initial conditions, interactions, and boundary conditions are performed without ever exporting the data. Instead, it's done by enriching the data at various stages. In ModSim loop, the simulations are updated automatically. If there are any changes to the initial design, this is revolutionary compared to the traditional processes, where you may have to start over. In addition, design exploration through the automation of parametric design space is an integral part of ModSim core processes. It allows for what-if studies and has a significant impact on efficiency saving. So in this slide, we have a quick example about the average automotive supplier response to nearly 500 RFQs per year, something like 2 RFQs requests for quotation per day, and you have only 2 weeks. Deadlines are expected by customer, so it's a slightly short time. So as we see the currently overall process in place, the data are siloed. Past knowledge may be carried over, but sometimes the cost of recovering data on non-structured system overcomes the benefits, leading to start from scratch or heavily depending on individual experiences. Third, the decision-making demands level of information that only tests costly and not time effective, and simulations can provide. Third, actions are taken only when data moves from silo to silo, slower when more design interactions are needed, not taking advantage of the collaboration. And final, later design improvement or extensive iterations that are carried eventually considered in the statement of work numbers. This is how we foresee the introduction of design evaluation process with ModSim. Within a collaborative environment, all data are accessible for the collaborators. Requirements and consolidated knowledge can be referred to and reused. Engineering templates can be leveraged to speed up design evaluation with minimum redefinition for simulation purpose needed. Streamlined proceed, easily usability of tools and fast learning curve provide designers with design simulation tools to evaluate and quickly interact with it. Ultimately, the democratization of the simulation solution, left shifting the design, completion, ownership, naturally improving the statement of work, time and quality. Sustainability is one of the strongest business drivers facing every industry. In recent years, organizations have had to adapt to. So during development, at the same time, the need to eliminate waste, reduce emissions, and innovate more efficiently is an urgent opportunity. So the traditional approach to product development and validation can take weeks. Designer designs product, sends CAD files to simulation expert. Then the simulation expert must first clean up or defeature the geometry, mesh the geometry, and prepare the simulation model for the type of physics to be analyzed. Defeaturing, meshing, and simulation preparation are usually different for different physics being analyzed. And once the simulation models are set up, the analyst runs the simulation, iterating in the simulation realms as necessary, and then reports to the designer, over times requesting design change. Then designer updates the design and the whole sequential process starts over. This is time consuming and inefficient. Comparing to that, the ModSim approach is the designer and analysts are working together on the same platform, always working on the most up-to-date models. No need to send files back and forth to one another. And within the 3D experience environment, associativity between CAD and simulation models is inherent, so simulation models can be automatically updated when the CAD model changes. When different physics need to be analyzed and different types of simulation models need to be built, those simulation models are associated with the same CAD model and automatically updated accordingly. Additionally, the ModSim approach also includes design acceleration with optimization and automation of multi-step, multi-physics workflows. And finally, the democratization, capturing best practices with automated processes and templates for designers and non-experts to evaluate multiple design configurations. So if you are talking about today, in 99% of companies, engineering and stress analysis are completely siloed. Designers handle products architecture, concept studies, and detailed design, while analysts take over later, creating finite element models, running simulations, and generating reports. And the problem, this back and forth is slow. If a designer requests validation from an analyst, it can take anywhere from a week to a month to get results. Different teams use different tools, leading to inefficiencies, delays, and errors. And if the design change, keeping everything in sync becomes a nightmare. And if a simulation runs for 24 hours on outdated data, it wastes valuable time and computing resources, and the current workflow is fragmented, inefficient, and costly. So how we can achieve a more streamlined and efficient process in a collaborative environment in which all involved can fully contribute? Our source of modeling and simulation, ModSim, built in two fundamental concepts: aggregating all knowledge, all design, all the results in one place, and connecting collaborators, products, performance, and processes. Automating means defining the saving actions so that they can be called again reliably without user intervention. The fundamental basis of this is the automation we can provide to connect a CAD geometry to its simulation model. The model updates simultaneously to the geometry. They coexist in a single world as a single entity. While democratization means allowing non-experts to access the digital twin and to benefit from it, because we automate, we can templatize. We save expert knowledge in a container that is accessible by anyone, for whom an update to the geometry or the design is immediately followed by an update in performance KPIs. Controlling and validating is all about feedback. Every working system needs feedback, and aggregator links structure for OEM company is no different. The speed at which you can take decisions and make changes it's also fully dependent on how quickly you can get feedback. All this come together to reduce costs, reduce time to market and risk, and ensure market-leading performance. One of the key enablers to realize new values through ModSim is something we call lift shifting. With lift shifting, we can reduce costs, increase insights into product performance, and reduce the risk of late-stage failures. Lift shifting the development process is made possible by investing in simulation in early design process. In the conceptual stage, as shown here, ModSim results in an overall reduction in time and cost compared to the traditional development process. Many customers are using our simulation technology with confidence to reduce and eliminate physical testing. Physical prototypes in the automotive industry, and as an example, can be as much more than $1 million, even with prototypes as much less expensive, such as in consumer packaged goods. Reducing the duration of concept development is a huge gain. First, operation engineering. In this domain, we focus on modeling our manufacturing processes. The objective here is to create a digital twin of our manufacturing environment. By utilizing 3D modeling simulation, we can design, validate, optimize our manufacturing system before they are physically implemented. This helps in identifying potential issues early on and reduce the risk of costly errors during production. The sequence we need to follow in this domain is creating MBOM from EBOM, defining process plan, and defining the work instruction. From building 2D layout of planet passing through, creating the right posture of workers in ergonomics module, designing and simulating the machines, finally, the factory flow. Now we will move to the second part after model and simulation resources. It's the orchestra of the manufacturing DELMIA: operations, planning, and optimization. No manufacturing environment can operate without a plan, and the plans must be made at multiple levels according to the time frames. In manufacturing operations, these 5 levels are sales and operation planning. Typically, this is the long-term plan. Production planning for the mid-term plans. Production scheduling for short-term. Workforce and logistics plans. Third, DELMIA operations management objectives are aimed at optimizing manufacturing operations through the effective use of digital technology. These objectives not only align with the pursuit of operational excellence, but also hold the potential to elevate manufacturing processes, optimize resource utilization, and enhance overall efficiency. And finally, we have the collaborative operations, which emphasize the importance of teamwork and information sharing. This domain enables seamless communication and collaboration across the departments, and stakeholders are involved in the manufacturing process. By integrating various teams and systems, we foster a collaborative environment where everyone has access to the latest information, making it easier to work together towards common goals. In the last slide, we will present the last video about digital manufacturing application, DELMIA. So let's see the video together.
In a disruptive world driven by experiences, we continue to imagine new horizons and expand our creativity to improve the modern world. With increasing global demand for the planet's precious resources, companies seek ways to operate sustainably without sacrificing competitiveness. At Delmia, we improve real-world experiences through virtual worlds using the Virtual Twin Experience. The Virtual Twin Experience is more than just a static digital twin. It is a dynamic digital model of your resources, products, and value network connected in real time. Real-time data is used to enable visualization, modeling, and simulation of complex products and operations, allowing you to make informed decisions and achieve greater optimization. Actionable data is an important part of the Virtual Twin Experience, enabling planning and execution to help you achieve your business and sustainability goals. With it, you can plan manufacturing facilities and operations to maximize efficiency, profit, as well as safety for your workforce. Leverage model-based engineering for virtual build and optimized process plans to achieve efficiency in everything from manufacturing to transportation. Have complete visibility across all functions and silos so you can make the right decisions to achieve operational excellence. Leverage a collaborative platform with lean operational tools to enable efficient global teamwork and workflows. Gain insights through closed-loop feedback to learn from past experiences and improve future operations. Analyze and simulate demand and supply. Optimize your value network with precision to ensure resiliency to ever-changing challenges. Identify and solve tactical operational challenges and respond with agility to schedule critical resources. Plan for success to ensure efficient warehousing and logistics operations for both inbound and outbound materials and last-mile delivery. By leveraging real-world data, you can direct materials, resources, and labor as needed to ensure flawless execution across global operations. Capitalize on knowledge and best practices shared by others on the cloud to ensure perfect first-time execution. Make every business decision a right one by having full IIoT connectivity between machines, products, and inventory, which allows real-time monitoring. This is a glimpse of the power that the Virtual Twin Experience can deliver for your business. It's more than just a digital twin. It's the connection of the virtual and real worlds that paves the way to resilience and opens the door to greater levels of innovation in your business. Take your first step towards operational excellence and sustainable global operations today.